Okay, this will be part 10 of the video series involving trigonometric integrals. Again, we'll look at problems involving secant and tangent. Now, in the last video, in part 9, we did a problem that just had the integral of the tangent to an even power. We had the tangent to the fourth power, and you might want to look at that video first because this one will be similar to it. And what we're going to look at this time will be the integral of the secant to the fourth power. Now, in a way, that falls under this first rule here. If the secant is even, if you want to, you can break off a secant squared factor and change the remainder to tangents, because that will allow you to put them in a form that you can find the integral of. Or you can just think of it as break the secant to the fourth into two secant squareds, and then you can change them into an integral that you can find and that you can actually integrate. So, as in the previous videos, you'll need a couple of identities first, so let's take a quick look at those again. Just a reminder, secant squared turns into 1 plus the tangent squared turns into secant squared minus 1. And then these are always important. The derivative of the secant is the secant tangent. The derivative of the tangent is the secant squared. So with all that in mind, let's take a look at the problem and see what they look like. Okay, now what we've got here is this. You've got a secant to the fourth power of this, and what we're going to do is to go ahead and split this up into two different parts. So we'll break out a secant squared and make this be the integral of the secant squared of 3x, and then have another secant squared of 3x. Then you've got a dx. Now, if you were actually staying with the rules, what it says to do is this, is factor out a secant squared, which is what we've done, and then change the remaining factors into tangent. And we'll do that, and again, the reason is to make sure that you can put it in a form that you can actually integrate. So what we'll do here is we'll go ahead and take this first one and make this be the integral of, and using this side unity over here, the secant squared, you can change it into 1 plus the tangent squared. Now, by doing that, that'll allow you to get in a form that you can find an antiderivative for. So again, take this secant squared and change it into 1 plus the tangent squared of 3x. And then you've still got this second secant squared here, and then dx. Okay, and the next step, you want to go ahead and distribute this secant squared through the parentheses. So what that would give you would be the integral. 1 times the secant squared would be the secant squared of 3x. And then this one times this one would give you plus, and this will turn into the tangent squared times the secant squared. So in a way, this is similar to that last problem we did in the previous video with secant to the fourth, but this one actually will not take quite as much work. Again, what you've got, look at the two integrals. You've got the integral of the secant squared, and then you've got the tangent squared secant. Now, both of these you can find an antiderivative for. So the antiderivative of the secant squared will get you to tangent, and then on this one, if you let u be equal to the tangent, the derivative of the tangent will give you the secant squared, so you can actually integrate both of these. So what I would do next is, right now you've got the integral of two separate things, and I would split this up into two separate integrals. So we'll make this be the integral of the secant squared of 3x dx, and then plus the integral of the tangent squared of 3x times the secant squared of 3x dx. So split the single integral up into two separate integrals. Now the reason you're going to do that is now you can actually use substitution on both of these. So you have an integral for this one, but again, this is not just a simple x, so in this problem, you're going to let u be equal to 3x. When you're working with this one over here, you can think of it as the tangent of 3x quantity squared. So here we'll let u be equal to the tangent of 3x. So this time this is going to be, so again, we'll treat them as two separate problems. So we'll scoot things down a little bit. Now on this one, let's do the u substitution on this part. So this would be u is equal to 3x So just typical u substitution, the derivative of u with respect to x would be 3. That means that du would be equal to 3 dx. Now on this problem, you're trying to get rid of that dx right there. We don't need 3, so move the 3 over here. So 1/3 du would be equal to dx. This will replace this, and there's your u substitution for this problem right here. So it'll be 1/3 du. Now on this one, we're going to let u be equal to the tangent of 3x. So the whole trig function this time. Now, why? Because the derivative then, here's what we're going to try to get rid of right here. The secant squared of x, 3x. So go ahead and find the derivative. So the derivative of u with respect to x, the derivative of the tangent is the secant squared of 3x. But remember, this is composite. It's more than just a simple x. You have to take the derivative of what's on the inside, so you add a 3 out here. So that means that the differential of u, take this 3, move it back in front, 3 times the secant squared of 3x dx. Now again, you need the secant squared dx. You don't need the 3 here, so move it over to this side. And again, you'll get 1/3 du would be equal to the secant squared of 3x dx. Now again, this matches up with this up here. So here is the u substitution for this problem. So again, you just treat them as 2 separate problems. Okay, now down here then, this becomes the integral of, and you've got the secant squared of u, and in place of dx, replace it with 1/3 du. So this would be 1/3 du. You've got a plus. Then the integral of this one, this will become the integral of, and here you're replacing u with the entire tangent, so this will just turn into a u squared, and then replace the secant squared with 1/3 du. So that one's going to look like that. Now in both these, you can bring the 1/3 out in front, so we'll make this be 1/3 of the integral of the secant squared of u du, plus, and bring this 1/3 out in front, the integral of u squared du. So they look like that. Again, we'll scoot things down just a little bit. Okay, now go ahead and find those antiderivatives. So this one is going to be 1/3. Now the antiderivative of the secant squared would give you the tangent, so that will be the tangent of u. And then you've got plus, this will be 1/3, and this will turn in using the power rule. This will be u cubed divided by 3, and then we'll tack on a plus c for both of them. Okay, so this one would be, then the final step then, this would be 1/3 of the tangent, and replace u with what it's equal to. So on this problem, u is equal to 3x, so replace that with a 3x. Now on this one, the 3 times the 3 would give you a 1/9, and this time replace u with what it's equal to on this one, so u would be equal to the tangent of 3x. So the tangent of 3x, but it's cubed, so put a cubed here, and then tack on a plus c, and u would be done. Okay, so just a quick review of the steps again. Starting with a secant to the 4th, break it into a secant squared and a secant squared. And again, to be able to find an integral, using this identity here, change this secant squared into 1 minus tangent, or 1 plus the tangent squared. Then go ahead and distribute the secant, and now you've got them into 2 separate integrals, and you can individually evaluate both those 2 integrals. Now both of them will require u substitution, but it's pretty straightforward from there. And then if you do the u substitution, and again, the final step is go ahead and replace the u's with x's, and it looks like that. So there's an example of an integral of a secant to an even power.